So today we're going to dive into resilient drone and forest environments, hardware design, and testing. Forests often have dense vegetation that ground vehicles can't navigate, leaving it up to drones to travel in the open space higher up near the foliage. This dense foliage and numerous obstacles make drone flight challenging and risky. While various designs exist to protect drones from collisions, there's no standardized way to test their effectiveness.
For our 4 prototypes, we have propeller guards, a disc, tensegrity, icosahedron, and a cage. With these 4 prototypes, we were able to evaluate our test procedure. For example, we're able to test how each one of these designs behaves when in contact with different amounts of foliage. In order to ease into the process, what we did was we started by testing each of the 4 drones with simple drop tests to see their structural integrity.
With the foliage test, we put each structure onto the drone and flew them directly through the foliage. We used visual data as well as actuator data to compare each structure's stability flying through the foliage.
Also, always remember to keep a fire extinguisher nearby in case of emergency. To compare the prototype designs, we use what's called the analytical hierarchy process. This is a method of comparing alternatives using a set number of criteria and weighting those criteria, comparing them to each other. Take ours, for example. We set aside 7 criteria. These include how the drones performed in the drop test, how they performed in the foliage test, their setup time, their repair time, how much they weighed, how easy they were to fly, and how compatible each prototype was with the sensors. These criteria are then compared to each other in order to give them a weight, determining what's the most important thing to look for when deciding on a drone prototype. And from that, we got the results showed that the foliage test, how easy they were to fly, and their sensor compatibility came out to be the most important aspects. We then compared the prototypes to each other using these weighted criteria, and from that, we got the result that the optimal alternative was the propeller guards.